So to find the inverse of a matrix, we need to find the determinant of the matrix. First of all, let's talk about what we're doing here. To find the multiplicative inverse of a number, say 4, we would just say 1/4, because 4 times a fourth gets you 1. Everything cancels and it becomes 1. So that's the multiplicative inverse. The additive inverse of 4 is -4, because everything cancels and you have 0. So what we're trying to do here is we're trying to take a matrix M, multiply it by an inverse, and get the matrix version of nothing. Which in matrix, that means a matrix that has 1s in the diagonal that goes from left to right, whatever size it is. I just made a 2 by 2 up there, and 0s everywhere else. So our goal in finding an inverse is to find that M-1 matrix. I'm going to give you M, and we're supposed to find the second one, so if we multiply them together, we would just get a matrix that has 1s in that one diagonal and 0s everywhere else, because that's the matrix version of nothing. So we're going to take a matrix M, just a standard generic ABCD matrix, and we're going to find the inverse. The first thing to do when finding the inverse is we have to be able to take the determinant of the given matrix. And you should know how to take the determinant of a 2 by 2 matrix. It's simply AD minus BC in this case. It's painted on the wall. And so we're going to go 1 over the determinant. So we write 1 over the determinant of the 2 by 2 matrix. And we're going to multiply that by a 2 by 2 matrix that we are creating from the given problem. So 1 over the determinant times a new matrix. Okay, the new matrix, we're going to take the A and the D and we switch them. We take these two and we switch them. And this is not on the wall, so you have to know it. We're going to practice it. The other two, we don't switch them, but we change their sign. After you have your matrix, you multiply in whatever this 1 over determinant fraction is. You multiply that in using scalar multiplication to all of the numbers. And that's how you get your inverse. And it'll be a little more clear when we do a specific example here in a second. So we are going to find the inverse of 3, -2, 6, 1. And the first thing we're going to do is go 1 over the determinant of that matrix. So I believe the determinant is 1 over, well, I believe 1 over the determinant, which is 3 minus -12. Do you see that? Which is 15. The determinant of that 2 by 2 matrix is 15. You must understand why it's 15. Can you put this away, please? Thanks. Now, we have a matrix. We switch the 3 and the 1. So they are in new positions. We change the signs of the other two. So the -2 becomes +2, and the +6 becomes -6. 3 and the 1 switch places. The -2 and the 6 switch signs. At this point, you distribute the 1/15. 1/15, 2/15, -6/15, 3/15, and then you would have to give me that reduced. If any of the fractions can reduce, you reduce them. So it should look like this: 1/15, 2/15, negative 2/5, and 1/5. And so what we found is if we took the original question, 3 negative 261, and we multiplied it by our inverse that we found, if we multiplied those two matrices together, we would get this blue identity matrix. That's the answer. So the goal was to find what would we multiply this by to get this. And we're going to use this to solve some systems here in a second. We're going to actually use it for a purpose. But that's how you do it, and that was the goal. So now what we're going to do is we are going to solve a system of equations using what's called the inverse matrix method. We've already learned 4 methods of solving a system: substitution, elimination, graphing, and Cramer's rule, which was just the last section, Cramer's rule, 4-6. Today we're going to do the inverse matrix method. Step 1, make sure that your system is lined up. Like with Cramer's rule, we've got to have the x's lined up and the y's lined up and the constants over there on the right side. And then what you're going to do is you're going to find the inverse of the coefficient matrix. So with Cramer's rule, it would be the denominator matrix. We were taking these 4 numbers, 2, 3, 1, negative 4, and putting them on the denominator of Cramer's rule. Well, that same exact matrix, in this method, we're finding the inverse of it. So step 1 is finding the inverse of the coefficient matrix. All right, so the determinant, so here we go finding the inverse. The determinant is negative 8 minus 3, which is negative 11. So we have 1 over negative 11, which is negative 1/11, times, so we're going to switch the 2 and the negative, like so, and then we're going to switch the signs of the 1 and the 3. And then multiply in the negative 1/11. So my inverse looks like that. Is this our solution?
No.
Okay, that doesn't make any sense. That would be the solution, because we are looking for x and y. What is x? What is y? To where if I put those 2 numbers in, it works in both equations. So to say that this is our answer, that means you don't understand the question. Once we have the inverse, what we're going to do is multiply the inverse times the stuff we haven't used yet, which is what? 13(1). So now we have to do matrix multiplication, which you had a worksheet on. All right, I'm moving to a new slide here. It'll say the same thing. And matrix multiplication, if you remember, is set up like this. The first matrix is a 2 by 2. The second matrix is a 2 by 1, which means our solution is going to be a 2 by 1. The top number of the 2 by 1 is going to be whatever your first letter was. X, in this case. The bottom number is going to be whatever your second letter was in your equations, which in this case is y. So now we have to multiply a 2 by 2 times a 2 by 1. So we're going to take a dot product, 4/11, 3/11, dot 13(1). 4/11 times 13 is 52/11. 3/11 times 1 is 3/11. That's 55/11, which is 5. Okay, so the dot product, if you want to see it, was that. Up in the red. The second dot product is 1/11 to negative 2/11 dot 13(1). And that ends up being 1. So your solution is 5, 1.